Hello everyone, good evening. This is Sangeetha, Assistant Professor ECE Department, SNS College of Engineering. So in the last video we discussed about the architecture of 8086. So in the last video I have explained the BIU unit, EU unit and various registers. So in this video we are going to see about the register organization in detail. So there are 14 general purpose registers, that is there are 14 registers and 4 are general purpose registers. AX, that is your accumulator, it is used for arithmetic and data manipulation operations. AX can be accessed as two separate 8-bit registers, that is AH and AL. So AX, BX, CX and DX registers are 16-bit wide. Even though it is 16-bit, it can be used as two 8-bit registers. AH, AL, BH, BL, CH, CL, DH, DL. AH means higher order bytes, AL means lower order bytes. So the next one is BX, that is base register. It is primarily used for addressing data in memory, that is base addressing. CX is mainly used for a counting purpose. It is often used as a loop counter in conjunction with the loop instruction. DX generally used in multiplication and division operation. Also it has specific usage in IO operations. And the next registers are SP, BP. SP means stack pointer and BP means base pointer. So these are used for stack pointer is used to handle interrupts. And BP is used for different addressing modes. And next we will see about the segment registers, that is CS, DS, SS and ES. So before that I should explain about the memory. So the 8086 uses a segmented memory model. So in which the memory addresses are composed of segment value and an offset value. So the memory capacity of the 8086 is up to 1 MB. So the memory is organized into segments of 64 kilobytes each. So the segmentation allows the processor to address up to maximum 64 kilobytes with each segment. So the effective address is calculated by multiplying the segment value by 16 and adding the offset value. So the 8086 supports for various addressing mode, including direct addressing, register direct, indirect addressing, indexed addressing, based indexed addressing and relative addressing. So the memory can store both instruction and data, and it's accessed during instructions such as move, push and pop. Move, push and pop are related to stack segment registers. And coming to the segment register, CS is a segment register which is related to code segment in the memory. So the code segment registers are used to hold the starting address of the segment, each segment. For example, DS, that is data segment, points to the starting address of the data segment, and SS points to the starting address of the current stack segment and extra segment. So CS register, that is CS segment is used to store the instructions, and DS and extra segments, that is data segment and extra segments, are used to store the data in the memory. So segment registers are used to hold the starting address of the memory, that is segment. And index register, source index, it is used as an index for accessing data in memory, commonly used in string operations. And DI, that is destination index, it is similar to SI but typically used as an index for storing data in memory during string operations. So SI and DI index registers are mainly used during the string operations. Base pointer is used as a base address pointer for accessing the data on the stack. Stack pointer points to the top of the stack, used for managing the stack. And the next one is flag register. So it is a 16-bit register. So flag register is used to represent the status of the result. So there are 9 flags. 3 flags are status flags, and Status flags, that is CF means carry flag, PF means parity, auxiliary carry, zero flag, SF flag, trap flag, interrupt flag, direction flag and overflow flag. So there are 9 flag registers. It is mainly used to represent the status of the register. So for example, carry flag is set when there is a carry out of MSB in case of addition or borrow in case of subtraction. Zero flag, the flag is set if the result of the computation or comparison performed by an instruction is 0. And sign flag, this flag is set when the result of any computation is negative. And trap flag, it is the flag if this flag is set, the processor enters the single step execution mode by generating the internal interrupts after the execution of each instruction. And the interrupt flag causes the processor to recognize the external mask interrupts. Clearing IF disables these interrupts, that is IF flag. And the last one is direction flag. This is used by string manipulation. So this is the operation of the flag. And already we discussed about the memory segmentation. So there are memory is divided into 4 segments, and this is the physical address calculation. So segment address, the physical address is calculated with the segment value plus offset value, and it is multiplied by 10. The physical address is segment address into 10 plus offset address. Hope this video will help you to understand the 8086 registers and how the memory is organized. What are the registers used for memory, that is segmentation memory, and what is the operation of the flag register, and how the physical address is calculated. Thank you.